Well, good morning, everybody. Good morning, Asim. You made it, finally. So we are happy to be here today to talk about the work we have done with Pierre related to GPS tracker technologies. And during this talk, we will try to share with you the fun we had when we analyzed the security of such technologies. So, as introduced by Vin, we are a security researcher at the Mobile and Telecom Lab, Xenes Lab, Test and Validation Labs of Dark Matter. And we had the third friend working with us, Iman El-Shehi. She wanted to be here, but she had some exams. So, big up, Iman, and we are all with you today. Let's start with the topic of today, so GPS tracker technologies. So there are cheap devices that we can buy online, and basically they provide you specific devices that you can put on for specific applications, especially for expensive good tracking, people tracking if you need. For example, when you have to manage cars at a large scale. They are available everywhere. They provide you also mobile apps for iOS and Android. We have been buying a few of them, so they are here if you want to have a look at. One of them is in the Faraday cage we have built yesterday, because we will do some live demos during this talk. Basically, when we started working on GPS trackers, it was early 2018. We have been looking at the infrastructure of GPS trackers, devices, but we had no information about the device we were testing. So basically, it was a black box type of analysis. And we started with gathering information. So the first thing we have been looking at is basically if FCC reports were available online. And we had a look on the website. And we found basically that the tracker have been evaluated from a standardized test point of view. And here, for example, we have one of the models we have been looking at. In the report, you have everything you need to know about the hardware, the wireless interfaces, the network, what type of sensor they enclose, what type of specific technologies they may be using, how they work, and a lot of information about the way you can manipulate the trackers. There is a lot of interesting information related to network interfaces, wired and wireless. So we will see that some of them have interesting features. And we had also to work on the reverse engineering of the hardware with the support of the FCC report, the firmware, when we were able to extract it, and web apps that are put online to manage the tracker remotely, and also mobile apps. And for the web app, we also had a lot of fun, and we will show you what kind of vulnerability they have. So the general architecture is as follows. So basically, the GPS tracker is supposed to get the signal from the GPS satellites. Then they collect the data, and through the mobile network, they will send the location periodically or on demand if the user would like to request at a specific time the location of the tracker with the mobile apps. It's just based on sending an SMS to the tracker, and the tracker automatically send back the location of the tracker. So the user can use the web application on the smartphone. He can also directly connect on the web app online and get access to the tracker and the management interface. So as we can see here, there are a lot of points of interaction. So basically, we can use that as attack vectors, depending on what is the purpose of the specific attacks we try to launch against the tracker's technologies. We were not the only one working on that at the same time. We have seen very interesting studies released online. TrackMageddon is one of them, and it's basically focusing on web app security. So finding vulnerabilities in management web application provided by manufacturers. A second study, which is basically sending fake time and GPS location to, again, the web app. And also Fidus, which was the study of the most important GPS tracker use in UK, where the researcher was able to compromise more than 10,000 devices. A last interesting publication published by Zach Whittaker was a study from a security researcher where he was exposing one of the interesting new features they tend to introduce in GPS trackers, which are a microphone to provide the user the access to the audio environment where the tracker is located. Most of these studies have in common that they were focusing on the web app and how to compromise the tracker's location from the web interface. In our case, we wanted to have a look at more attack vectors, and we decided to work on finding new vulnerabilities, having fun, of course, by trying all the attack vectors we had in mind. So the first one was how to reverse the management protocol by using a fake base station. Then becoming active, manipulating the data by bypassing security features if they exist. Accessing the remote management server and custom protocols. So we had a look at what kind of vulnerabilities exist in the management interface and how we would be able to access other trackers' location. We also had a look at the hardware security. We opened all the GPS trackers we have been purchasing, at least the one we have been able to get, because many of those stay blocked at the custom. Reversing the firmware, finding vulnerabilities, and also having a look at the mobile apps and the web interface again, because there are interesting features that we will talk about. So we just went online, we went to AliExpress, we took the 10 most popular GPS trackers. We finally were able to get 3. 7 were either sent back or blocked at the custom. Even by sending them to France, it was a little bit complex, so we were not able to get them. But what we have seen from an infrastructure point of view, all the trackers have a lot of similarities at the infrastructure level. So even if there are a lot of resellers, there is a specific hardware sold by OEM, and they are used by different resellers where they just put their own label on them. Most of them are Chinese, and you will see that for privacy purpose, there is some question to ask yourself before using such technologies. So for starting the study at the RF interface level, we wanted first to hijack sessions and break the A51, but we found it easier to just set up our own base station and collect all the data we need to start. We published one paper in MISC where we focused on the methodology we applied during the research, and one scientific paper where we focused on the privacy issues introduced by GPS trackers. So those studies are online or in the MISC journal. So regarding the first attack scenario, which was not really an attack scenario, we just put our SIM card in the GPS tracker, set up our base station as we did here, and we just started to get data, all the different messages sent between the tracker and the infrastructure. What we have seen, basically, that they have very old basebands, so they don't support USIM, and we spent one day just to figure out that they're not able to handle them. Here, for example, we will just go on the website and register the tracker we have on in the Faraday cage, and basically that's what the user will have. So he will have the location, its specific location soon, because we are also doing another demo at the same time, I think. So we can create the account. Basically, the login and password are either the IMI of the tracker or the serial number, and the password is basically the same information. And no one asks you to change the password. So basically, if you have one serial number, you are able to brute force them because they are just incremented when they are produced. So from that specific part, we are already able to get access to the data of a lot of trackers. We also have seen that basically the full configuration is managed through SMS that we can see in clear text. And the first fail that we have seen is for any SMS we send to the tracker, the content of the SMS is sent back to another, to the server, and basically to the manufacturer of the tracker. So he is aware of any action you are doing on the tracker. Action that can be changing the password to lock the tracker, changing the, getting access to the location of the tracker, and other data we will see. So these are proprietary protocols over text messages in clear text, and yeah, you will see that the protocol is really easy. So as we said, set up the BTS. Every security researcher now has at least one SDR. We have here the Blade RF. With that, we have been able to get a lot of information quickly, especially about the authentication protocol, which is really unsecure. All trackers send coordinates to IPs in China, which is also something interesting. The traffic is not encrypted and is easily detectable. The password is sent in clear text. The serial number is used as a token and it's also sent in clear text. The SMS configuration is generic in the sense that all the trackers we have been looking at use the same management SMS command. So as soon as you have been able to look at the configuration mechanism, it is common to all trackers you will have a look at later. The only firewall, the only security feature that we call firewall is that the tracker is locked against a master phone number, which can be easily bypassed if you are able to spoof the caller ID when you send an SMS to the tracker. And the phone number of the tracker is supposed to be secret, but we saw that the phone number for some tracker, as soon as you put the SIM card, is sent to the manufacturer. So he is already able to get critical information that is supposed to be only in your hand. Let's go.
Okay, so we wanted to mainly do live demo. So currently we have a Blade RF. This laptop is running Yati BTS. So inside the Faraday cage, so we have a super nice setup, as you can see, with 2 antennas and 1 GPS tracker. Unfortunately, we are not able to get a GPS signal within the Faraday cage. So what we can do is we can sniff the live traffic on the GPRS interface. Everything is sent to the internet. As you can see, the tracker is sending a specific request to IP in China. So cname06sz-datacenter.com. So we wanted to do a live demo about that, but unfortunately we can do well. So what we can do is we can analyze other PCAP files. So for example, this kind of PCAP, as you can see, when we sniff the traffic, you send at first a SMS to the tracker, so you send just status. Then we sniff the traffic on the GPR interface of the Blade RF. And what we see is that everything is sent to China. So inside the packet, you have the serial number of the GPS tracker, the phone number of the sender, and the status, the content of the SMS. At first, we were thinking we did a misconfiguration, and it appears that it was not a misconfiguration. Up, 1 second. Okay. So this is live. This is a capture of the packet. Okay, not this one, okay. Next one. Okay, so basically we wanted to replace the content of the SMS, and we saw that everything was being sent to China. So we were a bit curious, and basically it means that when you want to configure a specific option like geofence or very basic option of your GPS tracker, everything is sent to China, even your passphrase, your PIN code. So we reversed the protocol in order to have fun. So we wrote our own GPS client. So basically, we don't need a GPS tracker anymore. We can send fake information. What is very strange is that this IP is located in China. But in fact, currently we are working in Abu Dhabi. So when we are trying to ping this IP, we have like 9 or 10 milliseconds between this IP and our workplace, which was very suspicious. So in fact, this IP is geolocated in China, but everything is hosted in Dubai. We were a bit suspicious about that. In fact, all the IP range is announced by Etisalat, which is the largest United Arab Emirates internet service provider. That's very strange. So everything is sent, and also nothing is written about that in the manual or in the privacy policy of GPS tracker. So we are currently expat. So we found a very good way to get SMS from banking services and stuff like that. So currently we have this at home in France. And we reconfigure the management server. So basically it's send everything to our server, and we can use online banking service. Also, we wanted to analyze this IP because this IP is a bit strange. So first things you do when you are doing something like that is analyzing all the ports. So we were a bit suspicious because basically you have a lot of TCP services running on this IP. And when you want to reach this IP over HTTPS, so we will accept the risk. And you have this kind of website. So apparently it's a website for a Chinese bank. And if you read Chinese, it asks you to deactivate IPv6 and to disable your antivirus. Why not? A lot of suspicious services are running on this IP, so we changed because we found other interesting stuff. But this is highly suspicious. And so everything is sent to this IP. So we also analyze another kind of tracker. So when this other tracker is booting, so basically it will reach uBlock's server, so you can find a lot on Shodan. And the first thing is that, so we hide some information. It will use a specific Gmail account with a password account, and it will send latitude, longitude, and altitude directly to this server. Very strange. And then the client running on the GPS tracker will reach another TCP server, and it will send information. So as you can see, it's very straightforward to understand everything. So basically, you have in red the latitude and the longitude in red also. So now the question is, how does the authentication work? In both cases, as you previously saw, we didn't see password or encryption. And that's true. So you don't have authentication. So what we can do? We can write a small client in Perl. And what we did is we send fake coordinates specifying that our GPS tracker is currently located in Pyongyang. So we never went to Pyongyang. So we can suppose that it's not legit coordinate. And also, what is very interesting is that it's very easy to guess serial number of GPS trackers. So basically, if you are a bad guy, you can send fake information to like hundreds of thousands or millions of GPS trackers, saying that everyone is doing a party in Pyongyang. Maybe a live demo?
Yes, live demo, let's go.
Okay. So now I have a small client. I'm sending information. So this is This is a GPS tracker. I hope it will work because, as we will see, some things are broken in the backend in the Chinese infrastructure. So this is the information about this tracker. So currently it's in green. It means that it's getting all my information. So we are here. Let's refresh. Can you see it? We will refresh the web page and wow, we traveled. Incredible, super fast. So now I don't know where is the tracker. Traveling, having fun, I hope. Where I am. Yeah, so you can see we can create fake information for a lot of GPS tracker. It was not very complicated to do because you don't have authentication, and we can analyze the protocol very, very easily. Now, more active radio attack. You can do GPS spoofing. The fact is you can get a lot of program on GitHub and do it very easily. We were more interested in the detection of GPS trackers. So basically, as Shoki explained before, you can send specific SMS to tracker and you will get information back. What is very interesting is that a lot of commands, they don't require authentication. So basically, if you want to detect a GPS tracker using SFR SIM card, you send a specific keyword to all the SFR phone number, and you will get a lot of answers from angry people, but also from a valid GPS tracker. And also what is very interesting is that you can redefine the management server. Why is it super interesting? So basically, you can redefine this server in order to do man in the middle over the internet, which means that from the tracker, you are unable to verify or to check that the management server was changed. And using the balance program, you just do a TCP forwarding, and then it will send all the information back to China, which means that you are doing a man in the middle over the internet, and you are getting all the information. But also, if you are using BetterCap or MITM proxy, you are able to change on the fly a GPS coordinate, which can be very funny to do. But if you want to do that, use a Faraday cage. As you can see, we have a very, very fancy Faraday cage here. And don't do this at home because it can be a bit illegal.
It's just regarding the devices we have been looking at and the trend in the GPS tracker technologies. We have seen that they tend to introduce new additional sensors. The one on the mic, with the mic, we have seen that there are a lot now sold with the feature to eavesdrop the audio environment, movement and noise detectors also that will trigger the transmission of a specific location when they detect a specific noise level. We also have seen that a few devices now have cameras enclosed in the device, so you are able to request a picture anytime from your phone, and you will get it back. We also have seen additional wireless interfaces. The first thing would be to think that they add wireless interfaces to increase the connectivity of the trackers, which is completely wrong, because what they do, they added a Wi-Fi module with in a monitor mode to collect all AP parameters, and they send that back also in China. So we can think about cars having GPS trackers equivalent to the Google car that collect all information and send them back to China. So it increased the attack surface, but it also increased the capabilities of the tracker, which is scanning for access points in the vicinity of the GPS trackers. So again, what we have seen with our the devices we have tested, so 3 GPS trackers, 3 different backends, but a lot of similarities at the infrastructure level. The Chinese IPs that are exposed by the devices are located in China. We found also some of them in Germany, and the one we saw in UAE with this crazy banking website presented to users. We have reverse engineered all the protocols so that this is down. We are able to analyze and detect at the network level any GPS tracker traffic. At the ISP level, we think that it's super easy to detect the presence of GPS trackers, as it's really easy to detect specific messages from the network side. So, and they also can get the coordinates and modify them if needed to protect the information, the critical infrastructure that these companies are able to map today. In the same time, we have seen that there are interesting APIs, and now we will switch to interesting vulnerabilities we have found in the web apps.
So basically, this is a website. As you can see, we have a lot of functionalities. What is very interesting is that you have access to a lot of different APIs, allowing you to get a history of the tracker, to define geofence, and to get funny things. But before showing this kind of information, let's speak about hardware. So we also analyze the hardware of the GPS tracker. So mainly you have two different GPS chips. U-blocks, very common, and SIMCOM from a Chinese company. So you support GPS, GLONASS, Galileo. We found a lot of flash memory of 4 megabytes, mainly with ARM CPU on the motherboard. So we didn't find protection against physical attack. You have UART port everywhere. You have JTAG. So why we are doing that? We were mainly interested to found hidden commands and potential backdoors. So basically, we dump everything, and then we analyze. So it's very straightforward. We load the binary within the IDA Pro. We found Nucleus RTOS, which is a real-time operating system, and we were interested in finding backdoor SMS commands. So that was not a big success. Basically, we found different commands for different network protocol, but a lot of SMS commands are not enabled. So it was not a very big success. But also, what we found is that when you parse stuff, normally you can do a lot of error. So we were interested in sending bad information over SMS. And also, you have a client running on the GPS tracker in order to reach the management protocol. So it means that you have a parsing of information. Also, some trackers are supporting HTTP protocol. So they will reach a very specific HTTP server and do parsing of text file. This one is very interesting because basically no one tried to analyze this kind of security, and if you can do a man in the middle, you can send a specific HTTP packet and crash the GPS tracker. Also, when doing the reverse engineering, we didn't find anything about firmware updates, which means that if you found remote code execution or something like that, basically you can't patch. So you put everything to the trash and you buy a new GPS tracker. Then we also spoke a bit about different clients. So we also have iOS and Android clients. At first, we used static analysis using JADX for the Android client. So we had authentication, first time, yes. In order to get access to API access. So this one, we were very surprised to see that you have authentication. But the fact is, when you are authenticated, then you have a session. The problem is that the session is not linked to your GPS tracker, which means that you can fetch information about all the GPS tracker. So if an attacker about a GPS tracker, he will get a valid session, and then he can dump information about all the other GPS tracker. Also, everything is done over HTTP. So we try to find a vulnerability. So we found the insecure direct object references. So you can dump all the database. But it was already found by another team in the same time. And they already reached different vendors, and nothing was done. Also, we have access to specific API website. So this one, as you can see, this is a super API web page explaining you everything. So you can craft your request, and by default, they activated debug. So here you have the definition of all the API variables, everything you can do, which is super cool. So you can try to find good stuff. But the fact is it was already public, so we didn't continue in this way. Also, you have access to the website. So basically, the website, it allows you to define a lot of functionalities. So you have live information about speed, location. You can replay. So if you have access to all the history of people, it's very interesting. And also, you have geofence definition. So geofence is something you defined around GPS tracker. And if the GPS tracker is going outside this area, you will get alert. So you will get alert using SMS or push on application. This is a very good idea, but the problem is this functionality basically can be linked with the engine. So if the car is going outside the geofence area, your car may shut down. So it's not a good idea. We also found vulnerabilities, allowing anyone to define the geofence around your GPS tracker. So it's not a very good implementation. And also it blindly trusts GPS information, which means that if you are going to the peripheric and you send fake GPS information, you may have fun. But you can't do it because it's illegal. Let's do a demo about geofence. So for example, this one, we have a web page. So you can define geofence around this. Test. Test, test. Add success, yes. So I defined a very small geofence. So we also have another device. Hop. This is also ours. So as you can see, I was logged with my account, and I got access to another account, which is corresponding to a GPS we have. So we can define a new geofence. HIP, and giant. I want to be free. Yes, and it works. So basically, we define the geofence for another GPS tracker. This is a very good idea. The problem is the implementation is very bad. Also, authentication, in fact, on the website is very bad. Basically, if you have the serial number, the password will be also the serial number, or 1, 2, 3, 4, 5, 6. And basically, no one is changing this kind of password. Finally, I didn't speak about it, but you also have access to history. So it's very interesting. This vulnerability was existing 2 or 3 months ago, and you have access to a lot of very interesting information. You want to speak about it, Shadi?
Yeah, we can. Just for example, here we have found a GPS tracker that was used in Netherlands, and the tracker was going to a specific embassy every morning and going back home every evening. So it shows that the device is used also a lot in Europe. We found also some of them in France, but as it's started to be more offensive research, we decided to stop. We tried to inform the vendor, but it was really difficult to get in touch with them. We don't know what they are doing. But when we released the paper 3 months ago, we have seen that a part of the infrastructure and this specific part is not working anymore. So we don't see them patching things, we just see that it's broken. So either someone is playing with it, or they just don't have good software developers. And the question about the GDPR, we leave that for experts, but we have the feeling that it's not really compliant. So just to conclude this talk, we had a lot of fun. We hope that you also had a lot as us. We did the black box analysis of devices. The devices are used everywhere, and they are still available, accessible. So it seems that anyone using the device should just remove it from his car. The cell IDs are also collected with the GPS coordinate. So all the manufacturers have today the map of telecom infrastructure in all over the world, because we found the tracker everywhere. It's a very interesting topic because for us it becomes like a CTF style research, where we did reverse engineering, network analysis, radio analysis, and there is a lot of work to be done, and we hope that people will also work on it. And we thank you very much for your attention, and if you have any question, please let us know.